What's up, scholars? Today we're talking about similar polygons. So you did your investigation where you measured, here I'll just flip back to it for you. Ooh. You measured all these sides and all those angles, and you found out that the corresponding angles, like big angle A, little angle A, those were all congruent to each other. And the ratios of the sides were also equal. These ratios were all the same once I rounded that to the nearest tenth. So, going back in here, let's take some more notes about that stuff. Similar polygons. You guys know what the word similar means? It means kind of like something. It's not exactly the same, it's similar, it's related. And polygon, we've been talking about that for a little bit, a many-sided figure. So similar polygons are two polygons such that their corresponding angles are congruent and the lengths of the corresponding sides are proportional. Okay. The symbol, because of course we got special symbols for everything, symbol for similar is this tilde. Okay, so that right there is a symbol for similar. You may recall we also used this tilde before when we talked about not, where we had like not P. So it's not that in this case. We are recycling that symbol and using it for similar. So our statement of proportionality is an extended equation that relates all of the equal ratios in a polygon. For instance, if we said triangle XYZ is similar to triangle BUW, let me just draw that out real quick. Let's say that's X, and that's Y, and that's Z, and this will be V and U and W. Those angles are equal, those angles are equal, these angles are equal. Okay, so our proportionality statement, we're going to relate all of the equal ratios in a polygon. So side XZ related to side VW would have the exact same ratio as side XY to side VU. XY and VU will have the same ratio as ZY to WU. Oops. ZY to WU. So we are making a ratio of each of the corresponding sides, and that ratio is equal to all of the other pairs of corresponding sides. Cool. All right. Example number 1, let's write a statement of proportionality and list all the pairs of congruent angles for the following similar polygons. Can we see what happened? Like how these guys are related to each other. Like it rotated, and they got bigger. So let's list all the pairs of congruent angles first. I think that's easier. I can see that A is congruent to W. I can see that E and Z are going to be congruent. D and Y. C and X and B and V. Cool. Write out what we just said. Angle, where do I want to put this? How about over here? Angle A congruent to angle W. Angle B was congruent to angle V. Angle C was congruent to angle X. Angle D is congruent to angle Y, and angle E was congruent to angle Z. Okay, so since these are similar polygons, their angles are all congruent. Angles are all congruent, and their sides are proportional. So we have the shape A, B, C, D, E is similar to W, V, X, Y, Z, W, V, X, Y, Z, and we can write a proportionality statement for all of the corresponding sides. So side AB is going to be proportional to BW. So we'll do AB over BW. I wrote those backwards, but it's the same thing. Equal to BC over BX equal to CD over XY equal to DE over YZ equal to EA over ZW. So if you knew any three of these, you could solve for the fourth one. Right? If I knew any three of those, I could solve for the fourth one with my cross-multiplying abilities. Cool. Oh, that's where I was supposed to write that, and that's where I was supposed to write that. Haha. Great. Cool. Nice. Got it. Question 2. Decide if the quadrilaterals on the right are similar. If so, write a similarity statement and solve for A and B. Well, I see these angles are congruent to these angles. Got it. These angles. These angles. That's really all that needs to happen. All the angles are congruent. So, the quadrilaterals are similar. Yes, all corresponding angles are congruent. What kind of shape is this thing? Well, it's got opposite sides or opposite angles that are congruent. Who has opposite angles that are congruent? A parallelogram. A parallelogram has opposite angles that are congruent. Yeah. Okay, so we can say SRQP is similar to, S has 2 little markies, R has 1, so we need to go from 2 marks to 1 mark, so we'll say KLMJ. So we know KL and KJ. We need to find A and B. Okay, well, if this is a parallelogram because opposite sides, I keep saying that opposite angles are congruent to each other, opposite angles are congruent, then we know opposite sides are congruent because that's also true of parallelograms. So we know this guy is already 12. We don't have to work too hard there. We do, however, need to figure out A by using our proportionality statement. So let's set it up. SR over KL is going to be equal to SP over KJ. So I took the first 2 letters of each. SR over KL equal the first and last over the first and last. So we can fill these in with the numbers that we know. SR is 12, KL is 4, equals SP, that's the letter A we're looking for, and KJ is 7. So we got a ratio equals a ratio, or a proportion, which we will solve by cross-multiplying. A times 4 is 4A, and 7 times 12, 7 times 10 is 70, plus 14 is 84. Divide by 4, divide by 4. A equals 4 of them there twice, 21. A is 21. Cool. All right, nicely done, everybody. Looking great. Question number 3. In the diagram below, angle B and angle F. Angle B is equal to angle F, and it's 90 degrees. Well, I'm marking that up right now. Angle B is 90. You're also 90. Decide if the quadrilaterals are similar. If they are similar, write a similarity statement and solve for x and y and z. So we've got this little dude and the bigger dude, and they're sharing an angle. They share this angle D, so that must be congruent in both of them, right? We already have F and B are both right angles. I see that C and G are both right angles, so far these guys are congruent. This angle D is shared with the little one and the big one, so that's going to be congruent. And then both of them are four-sided figures, so that means all their angles add up to how much? 360. So I have 3 angles on the big one that are equal to 3 angles of the small one. They're all going to have to add up to 360. So I know what these angles are going to have to equal each other. There's no way around it. No way around it. So we have this quadrilateral ABCD is similar to EFGD. So we can solve for x and y and z using similarity statements. Like AB over EF, the first 2 letters in each, is equal to, let's do BC and FG. BC and FG. FG. Could plug in 16 for AB. Plug in Y for EF. BC is 12. FG is Z. Uh-oh, I've got 2 variables. That one's not super helpful. We're going to have to use a different ratio that doesn't both have variables. So let's do at AB over EF. That was fine. The tops of these guys, their ratio will be equal to, let's use some sides that we know both of. I know the bottom of the little one is 10. So DG, that's 10. Now we know the bottom of the big one too. We could add those up. The bottom of the big one, D to C, is 10 plus 14, so that's 24. So we could use top over top equals bottom over bottom. I think I wrote those backwards. Right? That should be DC on the top, or DG on the top, because the big quadrilateral side, EB was on the top, so DG, big, oh, that was right. I was right the first time. Oh, lordy, lordy. Look who's not even 40. Still making these goofy mistakes. Happens to the best of us, you know. So AB is 16, EF is Y, DC is 24, DG is 10. And cross multiply, we'll get 24y equals 160, divide by 24, divide by 24. I don't know what that is off the top of my head, so I'm going to go in my handy dandy calculator. Handy dandy, dandy handy. That's calling my brother. That was silly. You probably know the answer by now. 160 divided by 24. It's not a whole number. Is that okay? Yes. Yes, it is. 6.7 or 6.6 repeating. That's 6.7. I'm cool with. Okay. You're going to set up ratios and solve for x and solve for z. Doing great. Doing great. Scale factor is the ratio of the lengths of 2 corresponding sides of 2 similar polygons. All right. So, for example, you've been asked to create a poster advertising a school field trip to the Indianapolis Zoo. How cool! You have a photograph of the largest elephant, Sophie, which you would like to enlarge to poster size. Your photograph is 6 inches by 6 inches long. You would like the length of the poster to be 20 inches. How wide is the poster going to be? Well, let's set it up. Let's do width over length for both of these things. We've got the width of the photograph. Let's do that first. That's 4 inches over 6 inches. That will be equal to, because it will be in the same proportion or same ratio as the real poster, where the length is 20 inches. So the width is the thing we're solving for. Let's do some cross multiplying. 6 times x, 6x. 4 times 20 is 80. Divide by 6, divide by 6. X equals, that goes in once, remainder 2. That goes in 3 times, remainder 2. Looks like 3 repeating inches. 13 1/3 inches. Yep, there you go. That's how long it's going to be. A little bit over a foot. What is the scale factor? What does this say again? The scale factor is the ratio of the lengths of 2 corresponding sides of 2 similar polygons. So some corresponding sides. 6 inches in the photograph corresponded to 20 inches in the poster, so those are corresponding sides. So let's say 6 to 20, which we can reduce to, so we can divide both these by 2, divide by 2, 3 to 10 is our scale factor. Part C. What are the perimeters of the photograph and of the posters? Are these the same scale factor? Okay, let's do the poster first. 4 and 16. This one's going to be 4, not 16, 6. Add these together, 4 and 6 is 10. So that's going to be 10 and 10 is 20. The perimeter of the photograph, photo equals 20 inches. The perimeter of the poster is going to be, we've got 2 lengths that are 20, we've got 2 widths that are 13 1/3. So 13 1/3 times 2 plus 20 times 2 is going to equal 26 2/3 plus 40 is going to equal 66 2/3. So let's find the scale factor. Again, photo to poster. Let's see here. 20 to 66 2/3. Is that the same as 3/10? Huh. How do we even figure that out? What could we do? What can we do? What can we do? What can we do? Well, let's see. If we could somehow make this into 10 and see what that was related to that. Or maybe, let's see if 20 over 66 2/3 is equal to 3 out of 10. Let's see if that's true. Cross multiply. We're going to get 66 2/3 x equals 200. And let's do a little division. Hey, what do you know? That equals 3. So yes, they are the same scale factor. If you reduce this fraction, or actually what I did was made up a ratio here and set it equal to something over 10, because I knew this one was over 10. And I figured out if the ratios were equal to each other, and that when we solved we got 3, they would be the exact same scale factor. Yes. Awesome. Cool, cool, cool. Which leads us right into that theorem. Theorem 8.1. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of the corresponding side lengths. Awesome. All right, you have a couple examples to do for practice. These suckers. Ooh, look at all that fun things. You're going to do that one. And because you're beast mode scholars, you're going to do these challenge questions. Awesome. Cool. Love ya. See you next time. Keep on that hustle.